इसके नीचे तो व्हाइट में तो ब्लैक बहुत सारा
Where did we stop the last class? Okay, everybody focus here now.
Parallel combination, series combination.
Parallel where it started or?
No, we have to start.
Series combination is completed, right?
Yes.
So what is parallel combination? When resistors are connected like this, when both the terminals are connected with each other. So this is the circuit diagram for the parallel combination. Yes. So both terminals are connected with each other. In series, only one terminal was connected to the next terminal, right? So this kind of connection is called parallel. We now have to point out the equivalent resistance for the parallel combination of the resistors. So what will be the equivalent circuit? Imagine the combination of this is, let us say, RP. Okay. So now how do you get the circuit as? A So this is the equivalent circuit of the parallel component. You get me?
So what is difference between both of them? What is the difference between both?
Nothing. This is the equivalent of all the three. And we have to find the expression, the relation between this and that. Like we found for series RS is equal to sum R1, R2, R. So here we have to find the relation between equivalent of parallel combination and the resistors connected in parallel combination. Okay, so we basically make use of Ohm's law. So here, so what is happening in parallel combination? What about potential difference? Is it same or different across all the three resistors?
Different.
Potential difference.
difference will be
The
the same
potential
because one
difference will be
cell.
same.
It is same, right? Because this end is connected here,
Yes.
this is connected here. So all R1, R2, R3 are connected through a same potential difference. What about current? This current which is going, current is not separated. Yes, current is divided. R1, I mean I1, I2 and I3. In series, current was same, potential was distributed. In parallel, potential difference is same, current is distributed. This is the main difference. Okay, so current is distributed. So in parallel combination, current is distributed amongst resistors. Because there is different path for the current. In series, there is only one path. Okay, so all resistances carry same current in series. But here, the current is divided in three different paths. And over here, it will combine again. So it becomes I here again. Okay. So therefore, I is equal to I1 plus I2 plus I3. Okay. Same current I is divided here and now it is combined. So I must be equal to I1 plus I2 plus I3. So what is I here? Using Ohm's law, what will be I? So I is equal to V by Rp for this circuit. Yeah, because in this only Rp is there, only one resistor. Whereas here, what will be I1? V by R1. So this will be V by Rp. V by R1. I2 is V by R2. And I3 will be V by R3. This is my Ohm's law. Therefore, I is equal to V by R. This formula we have used here in this. And this is the total current in terms of combined resistance. So now V can be cancelled. So what do we get? Therefore, 1 by R parallel equal to 1 by R1. So this is the formula for, search it later now, first copy here.
So how did we cancel V?
Same all sides.
So we can just comment it out.
Obviously, you can multiply or divide V from both sides. So dividing V from both sides, V will be cancelled. So what will be Rp then? Rp will be reciprocal of the RHS. Therefore, RP is equal to okay, so this is the final formula. You take the reciprocal on both sides. So RP will be equal to 1 by 1 upon R1 plus 1 upon R2 plus 1 upon. So like this can be extended to n resistors. Let us say you have n resistances combined in parallel. So it will just go on adding 1 by R4, 1 by R5 till 1 by Rn. Okay, so this is the formula for parallel combination. Now, we'll do the example. So everybody understood the relation between parallel combination and the individual resistors. How do they combine? Just the reciprocal is added. Over there it was directly added. Here the reciprocal is added. Right? So the final parallel combination is reciprocal of sum of reciprocals. That's what you have to understand. What is the final RP? Lot of students make a mistake. I mean, this itself they say it is the RP, but it is 1 by RP. So final RHS का भी reciprocal है. Then you get parallel combination of resistors. Clear? So it will become clear with the help of example. Let's do example 11.8. So example 11.8, we will use the same circuit diagram. What is given here? R1, R2, R3 is 5, 10 and 30 ohms. Which has been connected to a battery of 12 volt. Okay. Calculate the current through each resistors. So you have to find I1, I2 and I3. I3 you have to find out I1, I2 and I3. This is part A. Part B, you have to find total current in the circuit. In part C, you have to find total circuit resistance, that is RP. This is what you have to find. So everyone read 11.8, given in your volume. Page 94. Where is your volume? ये कौन सा है? तो ले लो ना अपना, तुम्हारा वॉल्यूम किधर है? पीछे वाले का किधर है? फिर नहीं लाए तो आज?
सर मैं हर क्लास में बता रहा हूँ। सर फर्स्ट टाइम।
तो ये किसका है? उसका किधर है? इन दोनों बाहर जाओ।
सर मैं फर्स्ट टाइम।
नहीं तो लास्ट टाइम भी नहीं लाया था।
नहीं मैं वीडियो देख रहा था।
तो सुधर नहीं रहा है बिल्कुल भी।
सर सच्ची में आ गया एवरी क्लास।
है तुम्हारे पास वॉल्यूम? तू क्यों आया? तो ऐसे घूमने फिरने आया क्या? शर्म नहीं आती क्या तुम लोगों को? माँ बाप का पैसा बर्बाद करते हो इधर आके। शर्म वरम है कि नहीं? किसके किसके पास वॉल्यूम नहीं? हाथ ऊपर करो।
मेरा वॉल्यूम तो मैंने नहीं कहा, मैंने बोला है।
क्यों नहीं लाया तू?
वॉल्यूम बनता है।
मतलब ऐसे ही आ जाते हो, कुछ भी सेंस नहीं है बिल्कुल भी, ऐसे ही आके बैठ गए बस। तुम्हारा क्या है? लाया? What about you? मिला तुम लोगों को? जो टॉपिक चल रहा है टाइम टेबल देख के वो वॉल्यूम लेकर आना है, ठीक है? शेयर करो किसी के साथ। तुम्हारे डेस्क पे है वॉल्यूम? सब डेस्क पे वॉल्यूम है? तो तुम लोग क्या करोगे फिर? किसी पे 2 है तो एक शेयर करो उधर। ठीक है तुम लोग एक से काम चलाओ। और याद से जिससे लिया उसको वापस देना। खुद तो लाओगे नहीं और दूसरों का भी आराम करोगे जीना है। पढ़ो अभी सब क्वेश्चन 11.8 हो गया सब। टेक्स्ट बुक में सेम क्वेश्चन है। हाँ, ये टेक्स्ट बुक का ही एग्जाम्पल है, तो अभी एग्जाम्पल तक तो सेम है लेकिन बाद में नहीं मिलेगा सेम। सॉल्व हो गया सबका? So how will you find I1?
So I1 will be V upon R1.
देखो, it is the same circuit can be used. R1 is 5 ohm here, R2 is 10 ohm, R3 is 30 ohm. ठीक है? V कितना दिया हुआ है? 12. 12 is the total. So ये V और ये सेम ही होगा इस केस में. So you find out. So I1 will be, what will be I1? V by R1, which is 12 by 5. I2 will be V by R2, 12 by 10. कितना होगा? 5 to 2.4 ampere, 1.2 ampere, 0.4 ampere. So this is A. B में you have to find the total current. So I1 plus I2 plus I3. So this is 4 ampere. So what is C? So C is. So how will you find RP?
1 upon R1 plus 1 upon R2 plus 1 upon R2.
Yes. So 1 upon 1 by 5 plus 1 by 10 plus 1 by 30. इसका LCM 30 आएगा, वो ऊपर जाएगा। 5, 6, 3 plus 1. 30 by 10, which is 3.
3 ohm.
So RP is 3 ohm. So everyone got it?
Yes.
So straight application of formula.
So direct application question could come in exam.
Yes, anything can come. Right. Mostly this direct won't be there. There will be some twist will be there. But since you are starting, you should know. Start with direct questions first. we have $11.9. इसमें क्या? So this is the diagram for next question.
So we're supposed to draw this as well.
Yes. So this is the circuit for the next question. So what is given? R1 is given as 10 ohm. R2 is 40 ohm. R3 is 30 ohm. R4 is 20 ohm. R5 is 60 ohm. This is a 12-volt battery. So you have to find the total resistance of the circuit. R total. Then you have to find total current. This is also total. So how will you find it? Is this a series circuit or parallel circuit?
Parallel.
It's parallel completely.
No, it is those two resistors would come under series. The top and the bottom
So
combined.
this is two parallel network, and
One
then
makes
their
series
combination,
here.
whatever result you get here, and the result you get here, they are then in series. Whenever the path is same, okay, it is series combination. So one parallel here and another parallel here. The circuit will get modified like this. It will finally become like this. So this will be RP1 and this will be RP2.
Then we have to draw this out.
Yeah, I mean up to you. Why are you asking me this?
No, that second one.
I mean up to you. If you want to learn, you draw, or just watch and go. Draw it. Why are you even asking? I'm just saying that. You should draw. This is the equivalent circuit of this. So now this and this are in series. Okay? These two are in series now. So this is a hybrid circuit. It consists of both parallel and series combination. हाँ? क्या हाई क्या क्या पूछ रहे जरा जोर से पूछ हाइब्रिड बोला हाइब्रिड मतलब मिक्सचर पैरेलल और सीरीज का कॉम्बिनेशन है ये मतलब ये सर्किट अभी ऐसे है और ये RP1 क्या है पैरेलल ऑफ R1 एंड R2 RP1 इज बेसिकली व्हाट R1 पैरेलल टू R2 RP2 क्या है R3 parallel to R4 parallel to R5. Yeah. We have just redrawn it. ठीक है? तो ये दोनों सर्किट में कोई फर्क नहीं है, both are equivalent circuit. That's why I've shown this. Both are equivalent circuits. So how will you approach it? So what will be R total? देखो.
First we have to combine all the parallels, then combine the series.
You can do it in one step also. R total will be equal to first 1 divided by 1 by 10 plus 1 by 40. Then 1 divided by 1 by 30 plus 1 by 20 plus 1 by 6. The method in the volume and what I am giving could be different. So you can get it in one step.
Makes sense.
Because this is in parallel, this is in parallel, and
But
both
yeah,
are in series.
This is easier.
Yeah. So this is how you do it, because this is in series now. So what is it? So you take the LCM, 10 into 40, those are, or 40 is the LCM, right? So what you will get here? So basically you will get LCM is 40, 4 plus 1. What is the LCM for this? 60. So 2, 3, 1. This is how it will be. Here also, the LCM I have not shown here. Straight away 30. Everyone understood this step? How we did it?
Yes, sir.
You have taken the LCM and then the LCM goes up.
Inverse.
Yes. So here also you have therefore R total is equal to, what is it? 40 divided by 5 plus 60 divided by 6. So 8 plus 10. 18 ohms. So the first answer is 18 ohms. Page B. What is I total? So now that you have got the total resistance, so by Ohm's law, I total will be V by R total. Isn't it? Because I is the total current they are asking. So apply Ohm's law straight away. You don't have to separately calculate current. V by R total, isn't it? Okay? 12 by 18. So this is
0.6.
4, 3, 6 are 12.
So 0.6.
3, 4, 4 by 6.
0.67.
4 by 6. And this is 2 by 3. So this is 0.666. Okay? And when you round it off, it will be 0.67. Okay? This is our topic. Everybody understood how we did it? I total कैसे निकाला है? E upon R total is Ohm's law, right? Ohm's law से निकाला. समझ आया कैसे किया? तो प्लेन एप्लीकेशन ऑफ ओम्स लॉ है. समझ आया? Is this chapter taught in school?
Yes, sir.
Yeah, so for you both, you are excused right now, so just try to catch up things. Are you seeing the video lecture I told you in the last class? Is it making sense?
Yes. Sometimes voice recommendation.
Okay. But the written part, can you make out with that? So then you can ask doubt if you have any doubt. What doubts you have?
So right now it's not. I'm doing light sector first.
Acha, right now you're doing light. That's a big chapter.
Yeah. It's going to come in my class test.
So you can book a doubt solving request. Okay. So either me or Sudha madam, any one of us will help you with that. But those are short durations. Huh? So you read and then have doubts. Because otherwise 15 minutes will not be sufficient for that also. So book multiple doubt sessions. Let's say 2 slots at a time.
You can just get an extra lecture.
And you can get an extra lecture, those who want. Okay? Request for an extra lecture. All right. So with this, now we'll begin with heating effect of electric current. And after that, we'll be left with power. Shall I clear the board?
Yes.
Okay, let us start with heating effect of electric current. So let us draw this circuit for studying heating effect. Same circuit, huh? Again, just like Ohm's law, you have. This is the standard circuit diagram. So heating effect. What causes heating? What causes heating when the key is closed?
Sir, when the movement of the particles
Huh?
the movement of particles
What particle?
kinetic energy
Which particle is moving when the key is closed?
Yes, close and electrons.
Electrons. The particle is electron. So what happens to the electron?
They collapse.
They collide.
each other again.
They collide with the stationary positive ions. Yeah? So that causes heating. Okay? So still, even though it collides, right? But still, the cell will keep pushing them ahead.
Yes.
Okay? So due to which a current conduction will take place. So since the cell is working despite collision, cell is continuously pushing these charges to move across the conductor. Right? Cell's energy is spent in giving the kinetic energy to the electron all the time. Okay? So consider a charge. Since it's not one electron, I mean you have to combine. So many electrons are passing through the cross section, right? So consider a charge Q moves across the cross section. Of the conductor. In time t. When the potential difference V is applied across. ठीक है? Consider a charge Q moves across the cross section of the conductor in time t when a potential difference V is applied across it. So conductor okay. Let R be the so what is the work done by V then? When V is applied across the conductor, conductor has resistance R. Every conductor has resistance. So when resistance is nothing but the opposition, the measure of all the collision is resistance. So what is the work done by the potential difference in moving charge Q? Therefore, work done in moving charge Q is given as W is equal to Q times V. Isn't it? How do we get this? Work done is Q times V. Who is doing the work? Cell. What is the potential difference of the cell? V. And how V is defined? V is defined as work done per unit charge. How is V defined? V is work done per unit charge. So therefore W is equal to QV. Okay. Since we know that V is Q by W, W by Q. So therefore W will be QV. Correct? So this is the work done against the collision. So this work done itself is energy spent. Work done by the cell is actually energy spent by the cell in moving the charge Q. Isn't it? So what do you write it as? This work done is the energy spent by the cell against the collision between electron and stationary positive ions in the conductor. ठीक है ना? This work done is energy spent by the cell against the collision between electron and stationary positive ions in the conductor. So since it is collision and collision produces heat, work done is equal to heat in this case. Therefore, this work done shows up as heat energy. H. Therefore, H is equal to QV. Okay? This W itself becomes heat. Okay. Now, how can you write Q as? Because Q is moving in time t. That becomes current. Huh? So Q will be IT. Since I is equal to Q by T. Okay. Okay, motion of charge in time t is nothing but current. So I is equal to q by t. तो q क्या हो जाएगा? IT. जैसे यहाँ पे W क्या हो गया था? QB. So that's why we written IT. And by Ohm's law we can write V as IR. So this becomes I square RT. This is the expression for heat produced when current flows through the conductor of resistance R for time t. Okay, I square RT. Why did we write IR? Because since V is equal to IR. This is Ohm's law. So from Ohm's law, so basic equation is this, and rest is manipulation. Manipulation, I mean, just Q is IT and all that. This is called manipulation. Substitution. This is called Joule's law of heating. Above equation is called above expression. Above is called Joule's law of heating. So work and energy is two faces of the same coin. Energy spent is work. That is how you have to understand it. Okay? Will you be able to do any work without energy? No. So whatever work you are doing, you are actually spending equal amount of energy. So both have same units. Energy is joule. Work is also joule. Unit wise. Okay? So just recall the work energy concept from 9th standard. What is unit of energy? Joule.
It's the same as work.
Yes. So work and energy is same thing. Actually. So any questions in this? Just read through the text in your volume and see if you have understood it. What is the relation between joule and calorie? SI unit is joule. And heat energy unit is calorie. Right? So what is the relation between calorie and joule? So 1 calorie is equal to 4.18 joule. 1 calorie is 4.18 joule. Or it can also be written as 4.2 joule.
Which unit do we use to calculation? One unit or
Depends in the question how the answer you're supposed to. As if nothing is asked, SI, joule. Sometimes they will ask you to express the answer in calorie. Sometimes in the question it will be given in calorie. Different units will be given. So you may have to do the conversion. Here the answer will come in joule. So if you want to convert it in calorie, what will you do?
we multiply by 4.2.
What is joule? Joule is equal to 1 by 4.2 calorie. So divide by 4.2. Relations is given, no? Answer is in joules. Now I am asking you to convert in calorie. What is 1 joule? 1 by 4.2 calorie. Straightforward. समझ आ गया? So what is the next topic?
Practical application of
Okay, practical applications of.
heating effect of electric effects.
So application of heating effect of fan. So can you recall from your daily use what is the heating effect of current? Geyser?
Iron,
Yes. Electric iron.
Heater.
Do you use heater?
not over here, not in.
Not in
coastal
Mumbai,
regions.
right? But it is. Then what did I tell you? Geyser. Toaster.
Kettles, kettles,
Electric
Do we use electric kettle these days?
yeah, I guess.
Kettle, electric kettle.
Kettles are outdated.
No, it is not. But
Electric stove.
we generally we avoid this dip tea, right? We basically like boiled
Yeah.
milk mixed. It's like mixing things separately doesn't work in India, right?
Okay, yeah.
So electric kettle is that. Maybe for heating water.
Yeah.
Electric stove. Coffee machine.
Electric kettle. Okay, so these are
Electric stove.
use the examples given in your book. Electric oven, yes. Electric oven. So there are so many applications of
These are heat.
heating effect of electric current.
Electric bulb.
Electric stove.
Then one most important application is fuse. What is fuse? That passes electric current. Fuse हो जाता है ना? These days you have MCB, right? These days we are using what? MCB. It is a replacement of fuse. It's called miniature circuit breaker. Circuit breaker. So what is a fuse? Actually, fuse has fuse wire. So let me tell you what it is. So fuse wire is an alloy of lead and tin. Tin, metal, tin. So what is fuse used for? It is a safety device, first of all, isn't it? So why do we use fuse? Even a connecting wire provides current. Why do we need fuse?
It's safety measure something. My teacher
Like if
told
you
me.
take fuse out.
No, it's
Sir, if the electricity
electrical
flow gets
fires or something
more
like
than
that, right?
more than needed, the fuse.
Yes.
Yeah, exactly.
So when the current flowing in the circuit is abnormally high, this is called
Last year.
when current through the circuit flows abnormally high. When does that happen? When the current flows very high.
When the electrons
During some kind of accident like short circuit. Have you heard about short circuit?
Yes.
What is short circuit?
when the shirt
Sir, during rainy
shirt.
So short circuit is a situation, look here. When let us say this is the supply, your home supply. So it is providing you current. Supply से क्या निकलता है? Current. Then current has to pass through the load. Everybody look here, what is short circuit? This current has to pass through the load. But in short circuit, what happens? Basically, wire is always in pair, right? So sometimes when the insulation breaks, like wire has become too old and this thing has become brittle, and let's say electric iron, you use it so many times, it is twisted and it is broken. Then the live wire touches the neutral. So positive side is called live, this side is called neutral, and these wires travel together. Here in the circuit we are showing like a ring, but actually the wires travel together. If you cut a wire, you will see two wires traveling together. So one is live and one is neutral. So basically होता क्या है? ये जो वायर ऐसे जा रहा है, सेल तो एक जगह पे, ठीक है, ऐसे वायर साथ साथ चल रहा है. फिर जहां पे लोड है उसको कनेक्ट करके फिर से वायर साथ साथ ही आ जाता है पेयर में ऐसे. This live and neutral will touch each other once the insulation is broken. Then what happens is resistance becomes zero in the circuit. When this wire is touching here itself, resistance is outside, right? Now the circuit is completed here itself. It's not going to resistance. So when resistance is zero, what is the current? Current is V by R. So V by 0. This will become infinity. Very high current will flow. Okay? And when high current flows, what happens? Heat is directly proportional to square of current. When short circuit happens, then high current flows. It's not the other way. Okay? High current is the consequence of short circuit. Right? Then very high current flows and large amount of heat will be produced. Let us say, can you see these wires? These wires are flowing behind the wood. Okay? So, if now copper wire is not going to melt, it has very high melting point. So, if the heat is more than the ignition temperature of the wood, it will catch fire. This is why short circuit causes fire. Now we can avoid that. So let's say if large amount of current is flowing, right? So we connect a fuse here. In between, we'll place a fuse. So fuse डालने से क्या हो जाएगा? Now this is not copper wire. This is not copper wire. There is a fuse wire in between. You see?
This has a lower melting point.
Which has a much lower melting point than the connecting wire copper. Don't talk continuously. Are you listening? What did I say? What is the property of a fuse wire? So fuse wire has a much lower melting point as compared to connecting wire. So when a short circuit takes place, then fuse wire melts.
So the
Okay?
connection between
So the circuit is open. It's like open switch then.
So sir, that's why the current don't flow.
It will not flow. It will stop. So fuse over here, that means you come to know there is some overloading taking place. More than normal current is flowing through the circuit. So you have to investigate and fix the problem. Because without fixing it, if we reconnect the fuse wire, it will again melt. Okay? Now the problem with the fuse wire is unless you reconnect, let's say you investigated and repaired the problem. Now we connect the fuse wire. Unless you reconnect the fuse wire, the circuit is not operational. So it's a hassle. So nowadays we have MCB. So what happens is if any abnormal current flows, MCB just trips.
Yes, sir.
Okay? So it just trips. So now you know something is wrong. So you investigate, fix the problem, and just mechanically, so it becomes an electromechanical device. Just switch it off. Okay? So you don't have the hassle of connecting fuse wire. Is that clear? So how the fuses look is, you must have seen it. So every house must have a fuse connection, right? So fuse. Have you seen this? This one. This porcelain thing you see. So this is. Come here, come sit here. Come here. Come sit here. Penalty. So this is the fuse connection. These two dots. One side is connected here, one side is connected here. And the fuse, silence, look here everyone. The fuse wire is connected in between this. And this is now plugged here. When this is plugged, only then the circuit will operate. Okay? So we'll see the next. क्या नाम है तेरा? दक्ष. पूरा नाम बोल. शारदा. और तेरा क्या नाम है? दोनों बाहर आ जाओ जरा. तुम्हारा कुछ इलाज करो. चल आ जाओ.
कितना बड़ा होगा? 10 साल? 10 साल। 10 साल हो गए। कितना बड़ा होगा तो? ओवर साइज से बड़ा होगा। तेरा घुटना तो नहीं होगा। मुझे स्मॉल साइज मुझे बड़ी होती है। तुझे तो स्मॉल क्या है? डबल एस। ये जेंट्स का साइज स्मॉल है। लड़कों का साइज स्मॉल है। लड़कियों का साइज स्मॉल ना मुझे बताते थे। ये तो मेरी छोटी बहन पहनती है 6 साल की है। अरे सच्ची कोई साइज है? कोई बैठे नहीं वाला। टेस्ट है फिजिक्स। टेस्ट फिजिक्स स्कूल में। टेस्ट हमारे स्कूल में ना। हां ड्यूटी में नहीं। अरे तो स्कूल टेस्ट करने भी नहीं आई मैं बाहर में क्या अरे ती मिले हो रे एलिफेंट मिले होते अरे एलिफेंट का केवळ एलिफेंट नहीं मिले शी वेरी बैड आपस सब मेरे फ्री में किया जो शिफ्ट में फेरी से जाते हैं ना वो फ्री में भी खाना फ्री में खाया सब कुछ फ्री कैसे अरे भाई के पास पैसा है मेरे मुझे बुआ का बेटा है ना वो वहां पर आचार उसका रहता है क्योंकि वो वहां पर वो बस स्टेशन जाता है हम उसका जो भी मतलब काम है वो काम से मिल जाता है सब इसके टाइम पे हम लोग ये बाबा क्या बारी है उधर से है अरे पुराना कैसे हो गया चल लकड़ी कैसे वैसे नहीं मुझे मेरे लिए नहीं फिर भाई के लिए ये क्या है पर ये खाना रहता है ये क्या है इसको बोलूं ना नहीं डाल के खाना ये इसमें इसको खाना रहता है वाटरमेलन अरे चीज ऑफिस इसे इरेज होगा ना कुछ नहीं ये होता हाँ ये मेरे लिए होगा फिर चलो पेन खोल इसे लॉक किया अच्छा इसे मेरे में ये भी कुछ नहीं लगा ना कैसे ये मेरी भाभी के यहाँ पर ये बिजनेस से के इस मिलने के बाद सब देश जाएंगे ये लड़कियों का है ना बोल ये बोल रहा है लड़कों का बड़ा होता है नहीं लड़की और लड़का दोनों रहते हैं बस फर्क ये इफेक्ट नहीं आ रहा बड़ा आ गया मेरा और छोटा नहीं लड़कों का बड़ा बोलते हैं लड़कों को नहीं ये भी अच्छा लगता है लड़कों को बस फीलिंग होती है सलमान खान मेरे भाई ने ना 150 रुपए का इसका वो किस होते हैं ना कटाना रियल टाइप का कटाना छोटा पीछे पागल तेरा वो बैडमिंटन वाला भाई तो वही मेरा भाई असली भाई है वो मेरा असली मतलब नकली भाई इकलौता भाई है वो मेरा नकली भाई भी होता है क्या हाँ कैसे तू अरे वो मारते हैं
कोण सा मला कुछ काय बोलायचं
अरे ये बोलते हैं नकली भाई भी होते हैं मतलब हाँ